Hey guys, welcome back to another Algebra 2 video. Today we're going to talk about substitution. So we looked at graphing to solve systems of equations, and today we're going to look at substitution. And substitution is exactly what it sounds like. You have all been in classrooms where the teacher was sick and unable to come, but school still continues. And so there is a substitute that comes in the teacher's place. So what substitution is, we take out one thing and we put something in its place, just like the teacher leaves the room, another teacher comes in and takes their place. So we're going to use substitution to solve the system. The first thing we always want to do when we're solving substitution is make sure that we have a variable by itself in one of the equations. So I'm looking at my two equations. I have 3x minus y equals -7. And I'm looking at the second one that says y equals 4x plus 11. This y is all by itself on one side of the equal sign. So this is perfect. This is what I want. So looking at this, I'm saying, okay, y is the same as 4x plus 11. Doesn't look the same, but the equal sign tells me that they are equivalent. They're equivalent. They're equal. They can be replaced with each other. So I'm going to come over here to this equation, and I'm going to highlight this y over here. I'm going to do it in purple. I've got this purple y over here, and this is telling me that y equals all of this. So what I'm going to do is I'm going to rewrite my equation, and I want to keep the 3x and the minus, and I want to keep the equals -7. But instead of this y here, I'm going to put in place of it what y is the same as. So 4x plus 11. Now notice I put it in parentheses because there's a minus outside of here. So this says minus y, so I'm minusing what y is the same as. So I'm going to have to distribute this y throughout my equation. So let's just go ahead and solve. 3x minus 4x minus 11 equals -7. So we can go ahead and simplify. 3x take away 4x is -1x minus 11 equals -7. I can see that this is a -11, so to get rid of it, I add 11 to both sides. So -1x equals -7 plus 11. They're different signs, so I subtract. 7, 8, 9, 10, 11. That gives me 4. The bigger of them is positive because I'm adding 11. So it's a +4. Now I divide both sides by -1, and x is equal to -4. There we have it. We've solved for x. Now we need to know what is the value of y. So y is equal to, according to this, 4 times my x, which again I'm substituting this value in, -4 plus 11. So I get -16 plus 11. They're different signs, so I subtract. 16 take away 11 is 5. Keep the sign of the larger number, so it's -5. So my solution is -4, -5. I always recommend checking this with both equations. You'll know immediately if you got the problem right or wrong. So 3 times -4 minus a -5 should equal -7. So -12 plus 5 should equal -7, and it is true, it does. Okay, according to this one, we should have -5 is equal to 4 times -4 plus 11. 4 times -4 is -16. 4 times -4 is -16 plus 11 is in fact -5, so it's true. It works for both equations. So my solution to this system of equations found by using substitution is -4, -5. And if you want, you're always welcome to go to Desmos and graph it and check and see, do the 2 points intersect at -4, -5? Another great way to check yourself and just see, make that connection that it doesn't matter which way we do it, we're going to get the same solution. If we graph them, those lines are going to intersect at -4, -5. If we solve using substitution, we're going to find that the point -4, -5 lies on the graph of both of these equations. All right, so let's try this one. 5x minus 3y equals -25, and x plus 4y equals 18. I see a little bit of a problem. I don't have any variables totally by themselves on either side of the equal sign. So we're going to have to do a little bit of work before we can solve using substitution. Looks like it'd be pretty easy to get this x by itself, right? All I'm going to do is take this 4y and move it to the other side. So I have x equals, if I move 4y to the other side, to get rid of it, I've got to subtract it from both sides. So it becomes a negative 4y, and I have a positive 18. So this is going to be what I substitute, but this time instead of substituting in place of y like I did in the previous problem, we have x equals this. So I come to my equation, I want to circle my x, and I want to take it out, and in its place, I'm going to put what x is the same as. So I'm going to rewrite the problem. 5, we'll leave some room. In place of x, I'm going to put what x is the same as, minus 3y equals negative 25. So everything stays the same. The only thing that changes is I take out the x and I substitute it in with what x is the same as, what x is equivalent to. So that's that negative 4y plus 18. All right, now I'm going to pause the video and work this out. I recommend that you pause the video and work it out. Give it a try and see if you come up with the correct solution. Okay, so I began by applying the distributive property. I distributed this 5 to both terms inside the parentheses. I still keep noticing that students only give it to the first one. When it's outside the parentheses, you've got to multiply it by both things inside of the parentheses. So 5 times negative 4 is negative 20y. 5 times 18 is 90. Bring down my negative 3y equals negative 25. Then I changed the order. If you recall, the commutative property allows me to change the order. I did that so that my y terms were beside each other. I kept the sign that was in front of it. Negative 20y minus 3y is negative 23y. I subtracted 90 from both sides. Properties of equality tells me to get rid of it. If I subtract it from this side, I must subtract it from this side. So negative 25 subtract 90 is negative 115. Divided both sides by negative 23, and I got y equals 5. So we're almost there. Now we're going to take what y is the same as, substitute it in place of our y, and solve for x. So I've got negative 20 plus 18. X is negative 2. Again, check it, and you don't have to write it all out. Just grab your calculator, type it in. 5 times negative 2 minus 3 times 5 gives me negative 25. I don't know if you can see that, but it worked. I did it correctly. So now let's do the next one. X, which is negative 2, plus 4 times y, which is 5, equals 18. Boom, checked it, got the right answer. So I know that my solution is negative 2, 5. Again, if I was to graph these, they would intersect at the point negative 2, 5. All right, so I would like for you to pause the video and try this problem, show your work. Hopefully you've paused and you've realized that we need to take what y is the same as and plug it in place of this y. So I've got 4x plus 2, and in place of y, I'm going to put what y is the same as, and then keep my equals negative 8. I like writing with the white better. It's easier to read, isn't it? So again, applying the distributive property, I've got to distribute it to both things inside of the parentheses. 4x minus 4x minus 8 equals negative 8. All right, well, this was nice. It lined up for me. So 4x take away 4x is 0, and I have negative 8 equals negative 8. Well, that's a true statement. So what does that mean? If I solve and I have no variables left, but I end up with a true mathematical statement where negative 8 is equal to negative 8. Think about that. What do you think that would mean? Well, let's look at it this way too. Going back to graphing, if I was to move this, if I wanted to graph these, I'd have to put them both in slope-intercept form, right? So I'd have 2y equals negative 4x minus 8. I move the 4x to the other side, divide everything by 2. So y equals negative 2x minus 4. That looks oddly familiar, right? It's the exact same line. So that means that if I was to graph them, I'm going to have one line, that have a negative slope, so they should be going down, right? I would have one line directly lying over top of the other line. So that means that they touch on every single point. There's infinitely many solutions to this equation. So when I end up with a problem where all of the variables cancel out, but I have a true mathematical statement, negative 8 is equivalent to negative 8, then I know that there are infinitely many solutions. If there are infinitely many solutions, that means that it is consistent, right? Because there's a solution. So it is consistent. And the infinitely many tells, and it is dependent. So it's consistent and dependent. It depends on what point we're looking at. So this is the solution to this system is infinitely many solutions, and we would say it is consistent and dependent. And I just want to remind you that this one would be consistent and independent because there's only one solution. Independent people do things by themselves. Think about things that you already know and understand and relate it to the math. Independent, I do it alone. I don't need anybody's help. I am an independent woman. So an independent solution means there's only one. It's all by itself. Dependent means it depends on which part of the line I'm looking at. There's infinitely many solutions, so it depends on which solution I want, which one I can give, because there are infinitely many. All right, and the last problem of the day, I want to try to do this quickly. This video has gotten long, but is to write and solve a system of equations given some information. These are my favorite because these are the most applicable. Adult tree is said to be an adult tree if the diameter is greater than 10 inches. The same place says that if it's a sapling, then it must have a diameter that is less than 10 inches. So the city requires, if you're building a new building and you tear down some trees, that you must plant 2 new trees for each felled adult tree and 6 new trees for each felled sapling. So what that means is that every tree they cut down, they have to measure it. If the diameter is greater than 10 inches, then they've got to plant 2 new trees to replace it. If the diameter is less than 10 inches, then they have to plant 6 new trees to replace it. So at this certain building site, 167 trees were cut down, and there were 42 replacement trees planted. Blah, blah, blah. It's a tongue twister. How many of each type of tree were felled? So we got to think about this for a second. First, I always like to begin by saying, okay, which variable am I going to let represent what? So let's just let X be adult trees and Y be the saplings. And it doesn't matter which one. We could change this. Just however, whatever we start with is what we have to stick with throughout the thing. So I'm just saying let X equal my adults, Y equal the saplings. We know that there was a total of 167 trees cut down altogether. So however many adult trees they cut down, plus however many saplings they cut down, gave us a total of 167 felled trees. Now they replaced them with 742 trees. So they planted 742. Well, we know that for each adult tree, they had to plant 2. So 2 times the number of adult trees they cut down. Plus they planted 6 for each sapling that was cut down. And then that gave them a total of 742 new planted trees. So now that I have written the equations for you, pause the video, get one variable by itself, plug it in, use substitution, and solve. Okay, I went ahead and worked it out. I solved to get y by itself. Maybe you solved and got x by itself. It doesn't matter either way. 167 minus x, then I plugged in place of y in the other equation. So if you solved for x, then you would have plugged it in place of x, and you would have been solving in terms of y. Either way you go, you end up getting x is equal to 65 and y is equal to 102. And I always tell my son, when it asks a question, you are to answer with a complete sentence. So how many of each type of tree were felled? There were 65 adult trees felled and 102 saplings. When you write out your answers, always begin with capital letters. Use punctuation. This might be math class, but we can still follow proper English protocol for answering a question. We write complete sentences. We restate the question basically in our answer. There were 65 adult trees and 102 saplings planted to replace the trees that were felled. And that is all I have for today. I hope this lesson made sense.